Okay, I don't know if I'm going to get to show all the steps here, but we'll be pretty thorough. You'll probably want to pause the video and take some notes at appropriate places. Here's the original function that we're taking the antiderivative for. And we need to use partial fraction decomposition to break this apart so we can take the antiderivative of each term. This is the partial fraction decomposition. Here's the antiderivative, and I'm pretty convinced that this is the correct answer because when I graph f prime of x, it's this black curve, it matches the graphs of f of x and little g of x. So I think this is the antiderivative. The question is, how do we get from here to here? So this board addresses the partial fraction decomposition. This is a linear factor that's to the second power. So we know that we can break this apart into fractions a over x plus 2 and b over x plus 2, the quantity squared. And then this is a irreducible quadratic factor. So that can be written as cx plus d over x squared plus 6. And now if we multiply this equation, both sides by the LCD of x plus 2, the quantity squared times x squared plus 6, we get this equation right here. And what we're going to have to do is multiply all this stuff together and equate coefficients. I just made a little note here that you might try to do something like this. Notice that when x is negative 2, the term with an a, the c, x plus d, these terms cancel out. And you can solve for b that way, but then you don't get anywhere else with any of the other a, b, or a, c, and d. So going straightforward to equate coefficients, here's kind of what you do. Multiply these two binomials, distribute the a. That's one set of terms. Distribute the b. X plus 2, the quantity squared times the cx and times the d. Square this binomial, distribute the cx and the d. And now a plus c is the coefficient of x cubed. That has to equal 10. So there's from the 10, coefficient of x cubed. Collect the x squareds, 2a, b, 4c, and d have to equal the coefficient of x squared, which is 20. So 2a plus b plus 4c plus d equals 20. We can collect the coefficients of the linear factor. So 6ax, there's no linear factor here. 4c, 6a, 4c, and 4d has to equal coefficient of x is 20. And at this point, since we know what b is negative 5, we don't really need that fourth equation because we can replace this b with negative 5 and solve that system. 3 equations, 3 unknowns. And you can solve that system however you want. I used an online Gaussian elimination calculator. I actually did it by hand first and found out that a is 4, c is 6, d is negative 7. We already know b is negative 5. So substitute those values here and then find the antiderivative term by term. Here's what that looks like. Antiderivative a is 4 over x plus 2, b is negative 5 over x plus 2 squared, and plus 6x minus 7 over x squared plus 6. Now we're going to have to divide this x squared plus 6 into each term of the numerator here. And so we've got the 4 times this antiderivative minus 5 times this antiderivative plus 6 times this antiderivative. Using u substitution here, u is x squared plus 6, so we need it is 2x dx, so we do something like this. And minus 7 times this guy. That's the hard one. This is where you have to realize that 1 over x squared plus 1 has an antiderivative of inverse tangent of x squared. We need a 1 here. So I won't go into all the details. Hopefully you know how to do that. But in the end, you want to do something like this. X over the square root of 6, the quantity squared, plus 1. If you picture a 6 out here, square this and distribute the 6, you'll end up with x squared plus 6. Okay, so that's where this 6 came from out here. And then, so then here you have to use u substitution. U equals x over the square root of 6, or 1 over the square root of 6x. So du is 1 over the square root of 6. So that means we need to put square root of 6 in front of the integrand. And finally, that's the inverse tangent of x over the square root of 6. There you go. That's a lot of work, a lot of busy work. But hopefully that gave you some idea. And if you have any questions, post a comment. Whoop.